Welcome back to MATLAB. In this video, we are going to prove that 6 to the power of 2n minus 2 plus 3 to the power of n plus 2 plus 3 to the power of n minus 1 divisible with 11. We are going to prove that this number is divisible with 11 by using the induction method. First step, I am going to say that our number is equal with P of n. I'm going to rename it. So, proof of induction says that the base case we have to use it in order to prove that the affirmation is true for smaller natural numbers. So, let's take the first induction hypothesis. We suppose that this is true for P of 1. Yes? P of 1 equals with 6 to the power of 0. In our case, 1 equals n. 6 to the power of 0 plus 3 to the power of 2 plus 3 to the power of 0 equals with 11. Yes? Which is divisible with 11. So, the base case is true. We go furthermore to prove that also for P of k, we have the relation 6 to the power of 2k minus 2 plus 3 to the power of k plus 1, yes, plus 3 to the power of k minus 1. Also, this relationship we have to prove that is true. Yes, it's the same relationship as the above. Now I show that P of k plus 1 so P of k plus 1 equals with 6 to the power of 2 of k plus 1 minus 2 plus 3 to the power of k plus 1 plus 1 plus 3 to the power of k plus 1 minus 1. Basically, I have replaced k with k plus 1 in order to prove that also for P of k plus 1 is true. So in this case, we have 6 to the power of 2k plus 3 to the power of k plus 2 plus 3 to the power of k. Results furthermore that 6 to the power of 2 multiplied with 6 to the power of 2k minus 2 plus 3 multiplied with 3 at the power of k plus 1 plus 3 multiplied with 3 to the power of k minus 1. Furthermore, we have 32 plus 3, we factorize now, multiplied with 6 to the power of 2k minus 2. In here, basically, I rewrite it 6 to the power of 2 as 33 plus 3. So we go further, plus 3 multiplied with 3k plus 1 plus 3 multiplied with 3 to the power of k minus 1. Also, we have in here 11 multiplied with 3 multiplied with 6 to the power of 2k minus 2 plus 3 multiplied with 6 to the power of 2k minus 2 plus 3 to the power of k plus 1 plus 3 to the power of k minus 1. So, in here, we have the same number, 6 to the power of 2k minus 2, with this one. Yes? So, this one is true. Yes, we know that it divides this with 11. So this number divides with 11. Also, this number divided with 11. So results that our initial relationship is true. So we have p of the k plus 1 divisible with 11 results that p of n, the entire number, divisible with 11. For n natural non-zero number. Yes. So results that 6 to the power of 2n minus 2 plus 3 to the power of n plus 1 plus 3 to the power of n minus 1 divisible with 11. So we come back to our initial number p of n, which is true in this case. 11 divides our initial number. That's it for today. Let me know in the comments what type of exercises you want me to explain. If you understood this exercise, hit the like and subscribe button.